Problem 13.24 Utilization of constraint resources. Firms always has limited resources and they have a different products. Therefore, they have to decide very carefully which products generate maximum profit under the limited resources. They have to divide their resources very carefully into the different products. This problem is about that. We have that company BTC, which manufacture line of dolls and dolls dress saving kit. Demand for the doll is increasing and the management requests assistance from you in determining the best sales and production mix for the coming year. The company has provided the following data. These are 5 different products of the company. These are demand for the next year, then the selling price, material, and direct labor. There are also some additional information. The company plant has a capacity of 150,000 direct labor hours per year. This is limited resource on a single shift. The company's present employees and equipment can produce all 5 products. The direct labor rate is 12 per hour, is expected to remain unchanged during the coming year. This is the fixed cost, and then variable cost per direct labor hour. All of the company's non-manufacturing costs are fixed. The company's finished goods inventory is negligible and can be ignored. Requirement number 1. Determine the contribution margin per direct labor hour expended on each product. तो एक जो डायरेक्ट लेबर आवर है उससे कितना कंट्रीब्यूशन मार्जिन जनरेट होता है हर प्रोडक्ट में। इसके लिए हमें सबसे पहले वी हैव टू कैलकुलेट द डायरेक्ट लेबर आवर्स फॉर ईच product separately. These are the information I took from this table. Okay. First, we need to calculate direct labor or we have direct labor cost per unit that is given. These are our 5 products. And these are direct labor cost for each unit of each product. This is total cost. Why if we want to calculate direct labor hours, how we can do that? We are given the direct labor rate, which is 12. So if we divide this total cost with 12, we can find the number of direct labor hours. So 0.4 direct labor hours are used on Mercy, 0.25 on Tina, 0.7 on Carrie, 0.5 for Lenny, and 0.2 for sewing machines. These are direct labor hours. Now we can calculate the contribution margin per direct labor hour for each product. So here we will do calculation of contribution margin. The same formula again. We have to make a contribution format income statement. First we will have sales. These are our products. Then we have selling price for each product. After sales we have variable costs. The first variable cost is direct material. It is given up here for all the products. Then we have direct labor cost. Third cost is variable manufacturing overhead, which is given right here, $4 per direct labor hour. So this is $4 multiplied with direct labor hours. This is our total variable cost for all the product. We can just sum it. Now we can calculate the contribution margin per unit of product. Calculate the contribution margin, sales minus total variable cost. We have this contribution margin for all the products. Next we have to calculate the contribution margin per direct labor hour. So what we will do for this one, we will take the contribution margin and divide it with the number of direct labor hours required for each product. This is contribution margin per direct labor hour for each product. Second requirement is the calculation of total direct labor hours required to make all the 5 products in the coming years. So we have estimated sales for each product. This is demand for the next year. And then we have direct labor hours required for each product. We can just multiply both of these and we can get total direct labor hours required for the next period. So let's start. Third part, second part, total direct labor hours required. Products are here we have products, then estimated demand, for each product, third we will need direct labor hours, which we have calculated over here. can just multiply these two columns, and this will give us number of hours required for each product. So Mercy required 10,400 direct labor hours. Similarly, Tina required 10,500, 25, 28,000, 23,000, and 90,000. Total direct labor hours required will be sum of all of these. 161,900. This will be the total requirement for the next year. Now come to the part number 3. Examine the data you have compiled in part 1 and 2 above. How would you allocate 150,000 direct labor hours of capacity to BTC various parts? We need 161,900 direct labor hours for the next year. But what we have is 150,000 direct labor hours. Therefore, we are short of around 11,900 direct labor hours. So we have to decide how we will allocate these direct labor hours. First, we have to see the contribution margin of each of our products. We have 4 different products. The highest contribution margin comes from Tina, 70.8. So we should make that product at maximum of its demand, which is 10,500. And then the next is Mercy, 62.72. We should fulfill its demand as well, which is 10,400. Third is Saving Kit. We should fill its demand as well. And then Lenny as well. The lowest contribution margin comes from Carry. So we should allocate minimum amount of our resources to Carry. So we can deduct our 11,900 hours from Carry. So currently Carry has Carry needs about 28,000 direct labor hours for next year. So if we deduct 11,000 and 1,900 hours from it, uh, what we will require is 16,100 hours for Carry. Now, if we sum all of these, so we will fulfill the demand for all of the other products except for the Carry, because we have a limited resources. So instead of producing 28,000 of Carry, we will make only 16,100 products of the Carry, and that's how we can allocate our uh, all the direct labor hours, which are 150,000. Fourth part: what is the highest price in terms of rate per hour that BDC company should be willing to pay for additional capacity? So currently the price is 12, as given here. If the BTC decide to fulfill demand of carry, like I mean, it decided to produce whole 28,000. So instead of using 150,000 direct labor hours, the BTC decided to utilize 161,900 direct labor hours. So what is the maximum price uh, it can afford? So 12 is the normal price, and 9 is the contribution margin, which can be generated through the selling of carry. So the maximum price that can be paid for this is 12 plus 9, which is the contribution margin, equal to 20. And that's the maximum price that BTC can pay for the extra units of carry. Fifth, identify ways in which the company might be able to obtain additional output so that it would not have to leave some demand for its products unsatisfied. So if the company wants to satisfy the whole demand, then how the company can do it? There can be different resources. Company can outsource its production. So if the company doesn't have capacity excess of 150,000, it can easily outsource. Uh, or maybe if the company has capacity, it can do some overtime to increase its production. Maybe the company can expand its operations or add another shift, hiring more people, or eliminate wastage. So in all of these options, except for eliminating wastages, all other are expensive options because you have to pay something. While if you supervise your workforce well, if you utilize your workforce well and eliminate wastages, then you can easily increase your production capacity.